Today we're going to continue talking about sines and cosines and other trigonometric functions, but mainly because about sines and cosines. Previously we defined those functions through a right triangle. So we said that if you take a right triangle, which is based on the angle we're interested in, angle theta, then the ratio of adjacent leg to hypotenuse of a right triangle would give us cosine. The ratio of opposite leg to hypotenuse will give us sine. But we also said that really the size of the right triangle doesn't matter, because the ratio is going to be the same no matter what triangle is, as long as the triangle is built on that angle theta. So now let's just use that fact, and let's use length of 1 as our hypotenuse. So C will be 1, right? Now if you look at our formulas for cosine and sine, we see that A becomes cosine, adjacent leg becomes cosine, B becomes sine, opposite leg becomes sine. So now what we see, well, something interesting. But let's continue. The next thing we're going to do, we're going to introduce coordinate system. So I'm going to put that angle theta to the origin of coordinate system. And I'm going to put the adjacent leg along the horizontal axis. In this case, if you look at this point A at the very top, coordinates of that point A are going to be my cosine and sine. And really, now if you look at what we got, we have no really use of the formulas on the left. Okay? So we can kind of say, well, what is cosine? No, just take your angle theta, build a right triangle that has hypotenuse of 1. In this case, your adjacent leg is going to be cosine. The opposite leg is going to be sine. So really, we don't need these formulas anymore. Let's get rid of them. But the next question we have is, or I have, is what's going to happen if we start changing theta? Obviously, the point A starts moving. But the point A, no matter where it moves, no matter what's happening with angle theta, this point A is going to be a distance 1 from the origin of coordinate system, always. So, and again, if you remember your geometry, you would know that what it means that no matter what angle theta is, the point A is going to lay on a unit circle with the radius of 1 and a center at the origin of coordinate system. All right? And that gives us another opportunity to kind of rethink our functions, cosine and sine. So what we can say, well, if somebody comes and says, this is angle theta, I want to know what cosine and sine of that angle are. You say, fine, let's create coordinate system. Let's draw that angle theta. And let's draw a unit circle around it. Find point of intersection of the circle and the orange line, point A. And the coordinates of this point are going to be my cosine and sine. And what I'm going to do from now on, I'm going to use that as my definition of those two trigonometric functions. Now, you can kind of start asking questions, why? What's wrong with our previous definition? It was perfectly nice. You know, we just defined the sines, cosines through the right triangle. Why do we need to change it? Well, I agree that definition is nice and relatively simple, but it has several limitations. The main important limitation is that by defining this angle theta as an angle in a right triangle, we are restricting the angles theta to be between strictly greater than 0 and strictly less than 90 degrees. Well, why is that? Well, if you remember your geometry, you would know that sum of all angles in any triangle is 180 degrees. When we build a right triangle, one of the angles is going to be 90 degrees. So it means that for the other two angles, we have only 90 degrees left. They have to share this 90 degrees between them. So, and that makes this angle theta to be between strictly greater than 0 and strictly less than 90 degrees. That's the range. But really, that's not a range which we are interested. Sometimes we are interested in that range. But sometimes we want to have other angles. We want to have angles more than 90 degrees. And that definition, unfortunately, doesn't work for that. But this definition does. So what are we going to do now? If somebody gives you angle theta, which is more than 90 degrees, so what you're going to do is say, well, hey, I'll start again with my right coordinate system. I draw my angle theta. Now I draw an angle between 90 and 180 degrees, but I could have any angle I want. I draw my unit circle. I find the point of intersection of the angle, of the yellow part of the angle, and the circle at point A. And the coordinates of this point will be my cosine and sine. Horizontal coordinate will be cosine, vertical component is going to be sine. All right, now we define cosine and sine. What about all other? Remember, we had 6 trigonometric functions. Now we dealt with 2. What about the other 4? We also define them through right triangle. What can we do about that? If you remember the previous video, I was kind of talking about how we can relate those other functions to cosine and sine. And those relationships worked for angle between 0 and 90 degrees. But what we're going to do now, we're going to just say that those definitions, those definitions, those formulas are going to work for angles, but pretty much any angles we want. So these are kind of the formulas we could use as definitions. Now, once we find sine and cosine, we can say the tangent is sine over cosine. Cotangent is the inverse, opposite, flipped function. So we define as cosine over sine. Secant will be 1 over cosine, and cosecant will be 1 over sine. So there's no problems defining these functions. And another good news is that the previous relationship between sine and cosine we had still works here. Now, a couple other things I want to notice. I want to point to you that when, in our case, we have an angle theta that is between 90 and 180 degrees. And we can see that cosine for that angle is negative, while sine is still positive. Okay? The other thing to note is that because we're talking about coordinates of the point A that moves in a unit circle, on the circle, cosine and sine will always be between -1 and 1. So it's a good thing to remember to check when you do some calculations and you find your cosine or sine outside of that range, either more than 1, less than 0, you know that you did something wrong. All right, that's it for now. In the next video, we're going to discuss angles. We're going to talk about how can we have angles between minus and plus infinity. See you then.